our last video, we looked at the quadratic formula and we saw three different types of solutions, either one solution, two unique solutions, or no real solution. And if you observe, they all depend on what happens under that radical, okay, when you apply the quadratic formula. In the first one we got 0, so there was one solution. The next one we had a positive number, two separate solutions. Negative number under the radical, no real solution. With that in mind, we're going to look at just that quantity under the radical, called the discriminant of the quadratic equation. And as we saw in those previous examples, just looking at the discriminant tells us the nature of the solutions to that equation. The discriminant won't tell you the actual solutions, but it will tell you how many there are. Okay, excuse me, and just as we just saw, if that discriminant is positive, you're going to have two distinct real number solutions. If it's equal to 0, there'll just be a single solution, which is actually repeated twice. And you can see because you'll be able to write it in factored form as a perfect square. And then if the discriminant is negative, there are no real solutions. I'm going to leave these two for you to practice, but I'm going to solve these two extra solutions that I just wrote out. So let's see how the discriminant works, and notice the question. The discriminant tells us the number of solutions. It doesn't tell us what those solutions are, okay? And, I forgot equals 0 in this. So that should be, it's got to be an equation, so we set it equal to 0. Okay, this one is already in the correct form, so I see that A equals 3, B equals 8, C equals negative 3. Okay, so what's the discriminant? And if you remember, we just saw the discriminant is, and let me have that there in front of us, it's b squared minus 4ac. Okay, so b squared minus 4ac in this case is just equal to 8 squared minus 4 times 3 times negative 3, which is, what, 64 minus a negative 36. Okay, and that becomes 64 plus 36, which is equal to 100. Now notice that's a perfect square. So if I did want to actually solve, I could go ahead and do that, but let's back up though. The question was, how many solutions do we have? And that is a positive number, so there are two distinct solutions. And if we wanted to find them, we just use the quadratic formula. Again, the discriminant just tells you the nature of the solutions. You actually have to use the quadratic formula to find them. So what's the correct quadratic formula? Again, using our a, b, and c, it's the opposite of b plus or minus the square root of b squared minus 4ac, the discriminant, all over 2 times 3. And I wrote it that way because we had already discovered that the discriminant was 100. Since that's a perfect square, not only are there two solutions, but there are two rational number solutions. And so what that tells us is that x equals negative 8 plus 10 over 6, and that is 2 over 6, which is 1/3, or x equals negative 8 minus 10 over 6, which is negative 18 over 6, which is negative 3. So we have two solutions, and why don't you get some practice checking that by factoring the equation to solve. Okay? So that's one option. When you get your discriminant, you could have a positive real number, then you have two unique solutions. Okay? Let's look at another example. Now, first step here is to put in standard form. If you don't have that form initially, you can't find the discriminant. Okay? So we'll do that. Let's multiply out 2x squared minus 4x equals negative 5. 2x squared minus 4x plus 5 equals 0. And again, if you like, that's 2x squared plus negative 4x plus 5 equals 0. So that tells us that A is 2, B is negative 4, and C is positive 5. Okay? Now remember our question, what is the type of solutions? I find the discriminant, which is b squared minus 4ac, and so that is equal to what? Let's see, negative 4 squared minus 4 times 2 times 5, which is 16 minus 40. Okay, so our discriminant is negative 24, so the type of solutions, we know that since it's negative, what's under the radical in the quadratic formula will be negative, so there are no real solutions. Okay, that's the quadratic formula and using the discriminant in order to find the solutions. Now just again, to remember, the discriminant won't solve it if it tells you the type of solutions. Then you can go forward using the quadratic formula, or in this case factoring, to actually find those solutions. The discriminant just tells you the nature of the solutions. Okay, thanks.